Welcome to this new chapter on lightning and electromagnetic interference, or in popular terminology we call this chapter as lightning protection. So, this chapter is divided into 4 modules. First, an introduction on the different types of lightning and overall features that are important for understanding its action on man-made systems. Then properties of lightning which has influence on protection, module 6.2, especially currents and charges and electromagnetic fields. Then we introduce some concepts of lightning protection regarding buildings in module 6.3 and communication towers or wind turbines in module 6.4. Now, what we can do in this chapter is very short survey in relation to electromagnetic compatibility. So, it will not be any comprehensive treatment of lightning protection. We have seen that the generic approach to solving EMI problems for achieving EMC. We have seen about zoning principles, that is system topology, control of interfaces, grounding or earthing, electromagnetic shielding, filters and surge protectors. Now, all these are applicable even for lightning protection. The only difference could be that in lightning protection we are often dealing with huge systems like a big building, a huge railway network or a power network, a nuclear power plant, things like that. But otherwise the generic principles are the same and the source is also very different from the generic EMI problem sources. Also, it was mentioned earlier that lightning strike to aircraft and the early accidents in the 1950s and 60s prompted a lot of research, and that led to the development of EMC. Now, if you look at how prevalent lightning is around the world, you can look at this map of lightning data from NASA published at this website. So, here this is from the NASA's lightning imaging sensor on the tropical rainfall measuring mission satellite between 1995 and 2002. So, this is average data. Now, the color coding is this: places where less than one flash occurred each year are gray or light purple, and places with the largest number of lightning strikes are deep red over here in the scale and grading to black. So, here blue means that it is less number of lightning, red means very large number of lightning. So, not surprisingly you can see that tropical Africa and tropical Asia has the largest number of the largest lightning flash density per square kilometer per year, around 70. So, in India in some places you have, and other places it is much less. In Sweden it is around 1 flash per square kilometer per year. So, lightning is very prevalent and it is there all around, and it will be there for years to come. So, earthbound systems are mostly affected by cloud to ground lightning, even though cloud lightning is more numerous. Cloud lightning is lightning within the cloud you can see that when you look up, but there is no flash coming down to the earth, whereas in cloud to ground lightning there is a flash coming down to the earth and striking the objects on the ground. So, we will be concentrating on cloud to ground lightning. So, this picture is provided by Dr. Hannes Pichler. So, this is a charge structure in a cumulonimbus cloud in the tropics. Understand like this: on the top there are positive charges and at the bottom there are negative charges. We will not go into the details on how these charges are produced and all, but it is enough to understand that most of the lightning originates from around this region, the negatively charged region. So, rather than the height, it is the temperature levels that is important in the electrification. So, you need to be above the freezing level. So, this is a cloud in the tropics, and winter clouds in other places can be much lower altitude. So, freezing level around 5 kilometers in the tropics can be much lower in winter storms or at higher altitudes. So, it will have a horizontal portion, the lightning channel, and the vertical portion. Now, these are the 4 types of cloud to ground lightning. So, based on the initial direction of the leader, you call it as downward lightning or upward lightning. 3 and 4 are upward lightning, these are downward lightning. And depending upon the polarity of the charge that is neutralized in the end, you have negative lightning as well as positive lightning. So, let us take the first example. You have this negative charge here. So, around the ground it is positively charged, and here there can be some negative charges. So, lightning here, the lightning is beginning with a negatively charged leader moving downward, and this is downward negative cloud to ground lightning. So, at the end of the lightning you have neutralized these negative charges, because as this is coming down and making connection to the ground, positive charges are moving up and you are neutralizing this part. So, effectively negative charge is neutralized. So, you call it as a negative cloud to ground lightning. Now, in the second one, you have a positively charged leader moving downwards from this positive charge source and coming to the ground. So, this is a downward positive cloud to ground lightning, because at the end of lightning you will have this positive charge neutralized or lowered to earth. So, downward positive cloud to ground lightning. So, here from tall structures or mountains you have an upward positive leader, and in response there will be a negative leader coming down, and in the end you will end up removing this negative charges in the cloud. So, it is an upward negative cloud to ground lightning. And the fourth one, negative leaders are going up connecting to this positive charge, and positive charge will be coming down, and in the end of the process this positive charge is removed or neutralized, not fully but only partly in all these cases. So, negatively charged leader moving upward from objects on earth, so they are upward positive cloud to ground lightning. So, of this lightning, the most important for us are this negative lightning, almost 90% of this of the lightning, cloud to ground lightning that we see are negative CG lightning, and there are some maybe around 10% or so of positive CG lightning. Upward lightning used to be usually from mountain tops, but nowadays there are much more incidents of upward lightning, mainly because of tall towers, either in the form of communication mast or in the form of wind turbines. So, the proliferation of communication masts and wind turbines has created new interest in lightning protection. Within a lightning, this is a still picture of close to a second. You have several strokes that you can see in the picture next. The difference is that this picture is taken on the same event, but with a camera that is moved sideways, so that the axis, the movement is like a time axis. So, shifted in time, you can see these individual strokes interspersed with some time interval between the strokes. So, each lightning event will contain several strokes. Upward lightning from mountain tops and tall towers. It is generally considered that towers of heights above 100 meter can initiate upward lightning. For example, very tall wind turbines and communication towers. So, below that it is less likely. Lot of studies on lightning are done by artificial initiation of lightning, by shooting small rocket upwards, and these rockets carry a wire pool at the end. This is taken from the experiments at University of Florida in Gainesville, USA, courtesy of Professor Villaraco. So, a rocket is shot upwards, and due to the highly intense fields, it produces charges. It is a charge leader, and in response to that, there is a negative channel. There is a channel coming down from there, and finally you have a normal kind of a channel established. Then after some time, the wire is burning, then you have created a plasma channel, and through that channel a negative leader is coming down to the place where we want the lightning to come down. Then you have a return stroke. You have to remember that the bright light that we see is not from the part that is coming down, but from the part going up, because Earth, being conducting, can collect large amount of charges in a short time, and you have a potential wave going upward at 1/3 to 1/2 the speed of light. So, it is this that we see as a bright flash, and the expansion of the air and later collapse will appear as a thunder. So, this is called the return stroke, the upward going part, and that is what normally we see with our naked eye. So, I will show one video from University of Florida on triggered lightning. So, we will play it again. So, that was the rocket launcher and this is the lightning rod. So, these are the various strokes within the lightning, only the bottom portion is shown over there. So, with this type of technology, you can make lightning strike any object that you want. So, this is a giraffe, a truck with a giraffe, and on that the launch pad, and the rocket is going up and creating a lightning. So, of course, there has to be thunderclouds above for successful triggering of lightning, and lightning can be struck to power lines or big transformers or something for testing purposes. Similar experiments are also done at a tower, communication tower of about 100 meter on a big mountain near Salzburg in Austria, courtesy of Aldis in Vienna and Dr. Gerhard Dindorfer. So, this is a lightning strike to that tower. So, here one can point out several interesting features. You can see first a wire, one channel, then you can see several channels in it. So, this is upward lightning. So, this is slow motion video. Previous video was also slow motion. That is why otherwise the phenomena lasts less than a second, you will not be able to see anything. See, all those branches were not visible, but the plasma channel was still active. That is why repeatedly leaders are coming down and return strokes are happening within that. And sometimes it may be just a pulse coming down. So, this tower also is used for not only for research on lightning, but even for investigating the effect of lightning on engineering systems. So, only some of this brightening are return stroke, others are just pulses coming down the channel called M components. Okay, I will stop it over there. So, this is just a brief introduction to the phenomena of lightning. That is not the focus of our study, and that we will come to the next stage. What are the real properties of lightning important for protection of engineering systems?